All right, so plenty of things to go through today. First, final exam. Second, expectations for final project. Third, we'll be going over PIG. Okay? So first and foremost, let's see. Let's see. I don't think we'll be able to have class next Tuesday because I'll most likely be driving home from the eclipse on Tuesday. So next Tuesday, I will make an announcement. Since I'll make an announcement, and that will involve me posting probably a video for you to watch of a previous lecture where I'd gone over some content. Let's see. But first, let's talk about final exam. Then we'll talk about proposal day. Final exam. That's because some people are trying to figure it out. First off, it's always worthwhile reading these documents that they give you and just not skipping over the verbiage. Right? So please, okay. Instructors are encouraged to work out accommodations with students who have more than 2 examinations scheduled on one day. So that means that basically if you have 3 exams, you should be on the same day for some reason, you need to talk to your professor and one of them should move out of the way. Okay? Make sense? Also, final examinations may not be scheduled on study days or in the last week of classes. Professors are not allowed to give you your final exam on the last week of classes. Okay? If they're doing that, contact the dean. They're not allowed to just kind of skip that process and not have to come in and give a final during this time just because they don't like it. All right. Some courses have common finals. Ours is not one of them. Instead, what the issue was that people were kind of looking for a class over here because you're registered for 4 hours. Actually, you want to look over the 3-hour courses because we're a 3 credit hour course. Sorry, we're 3 lecture hour, 1 lab hour. So because we're 3 lecture hours, you look over here for that time. So I'll make an announcement about this as we get closer to the exam. But since if we meet from 2 o'clock to 3:20, which we do on Tuesday, Thursday, then our exam is Thursday 5/2, which means basically that I will have to spend. So this is part of the reason why the final exams have to be in on time on Monday, right? This is part of the reason why I won't be really why there is no late penalties, because I have to spend all day Tuesday going through the final exam. So going through the final projects. Probably all night because I've got jury duty on Monday, so I'll be figuring out whether or not I will be actually available Tuesday to go through these projects. So we'll figure that will be interesting to know. Worst case scenario, I delegate that to the TAs and they give me a short list of what they think the best projects are in their class. Okay, but you will know, but my goal is that Tuesday evening people should know if they are missing the final, if they get to skip the final exam. Okay? So, proposal day. First off, if you met with me today, you get to just kind of, and we decided on a final project, you get to skip this. Okay? So, your proposal, and that applies to maybe 3 of you. I'm not sure why Canvas is not loading for me. Is Canvas giving issues for anyone else? No? Okay. Give me a second. Okay. Cookie. So, history, clear recent history, cookies, yeah. Yeah, just clear everything out, please. Yep. This is going to be annoying, but okay. So I'm currently cleaning that out. So anyway, you'll notice that on Canvas, even though I can't pull it up right now, that you have your proposal due tomorrow. Sorry, not on Thursday. So the way this will work is on Thursday, I want you to come to, not come to class because we won't do it in class. Instead, we'll be doing Thursdays over Zoom. Okay? And again, I'll make an announcement about this. Okay. There we go. Two-factor authentication. Yes, this is my device. And I'm just assuming that this was a weird thing with the cookies messing up. See, I can solve my own problems. All right. So proposal. So the proposal, right? Fill it out, and what you need to do is you need to come and meet with me, and I need to make sure that your project actually, makes sense for it. I'm basically my role here is that I need to make sure that the projects you choose are both not like ridiculously too easy, or if you're choosing something difficult, then to give you a manageable baseline deliverable to present to me. Okay, so you want to fill this out and have this turned in by Thursday evening. But here's the way it's going to work. Tuesday on 2 p.m. you're going to log on to Zoom. Those of you who need to be seen first, I will then open up multiple breakout rooms. Those of you who need to be seen first, join the lowered number breakout rooms, like 1, 2, or 3, depending. Okay, if you have class right after my class, join in room 1. If you can wait, join like one of the later rooms and go and watch cat videos or something. Okay, or work on something else, or otherwise just chill. It's going to be a while. Because this typically takes about typically takes about 2 hours for me to do, but I want to make sure that I can get to everybody. So just kind of if you can self-sort like that, that's great. And then I'll basically go around to every person and ask, okay, what is your project? And you'll say, oh, this is my project, or you'll say, actually, it's not just me, but these other people as well. I only need to hear from one person. I only need to hear from one person per project, right? If you're partnering with somebody, only one person needs to tell me what the project is. Make sense? Okay? So what I'll do is I'll ask, what's your project? And you'll say, it is, a visual novel. It's a website to buy stocks, or I want to build a homepage or something like that. Okay? If you come to me and say, I want to make Hangman, I'm thinking do Hangman or Tic-Tac-Toe, I'll tell you, well, that's a homework. That's like an easy early homework that we do in class, that we could do in class, that I don't do because it's not really that interesting. But let's go ahead and say you want to do Tic-Tac-Toe. I might say, well, Tic-Tac-Toe is actually not that interesting of a game unless you program the AI how to play perfectly, because it's a perfectly solved game. But honestly, that's not that interesting either. Instead, I would direct you to a game called Goblet Gobblers, which is tic-tac-toe, but with a twist, where basically you have small pieces and large pieces, and you can put your large pieces on top of the small pieces. It's actually a really good game. It's made for kids that age. And what you do is that you can put your large pieces on top of the smaller pieces, and it adds a strategic element. Implement that, and then maybe use Turtle or Pygame for graphics. Pygame doesn't even have to be used for very animated graphics. You can just use that to display circles and rectangles, and voila, you have now a game that you can use for, with basic graphics and stuff. So I might say, okay, if you want to do tic-tac-toe, you do this. If you wanted to do Hangman, I would tell you, well, we have Cheaters Hangman, but that's that's what we're working on in 2168 right now as a homework. But again, maybe you want to, I'd want you to possibly do graphics with Pygame. Not Turtle. Turtle is very limited in what it can do, and you have to wait for the turtle to draw stuff. Okay? So so basically, if it's too easy, I will direct you to something. If you come to me with a project and just say, okay, this is my idea, I'll most likely check it off because honestly, most of the ideas I hear are completely reasonable. If you come to me and say, I honestly have no idea what to do, I will ask you a few basic questions like, what are you interested in? Are you a CS major or what's your major? And then direct you accordingly. I'll try to do that very quickly. It's not because I'm not interested in you. It's because I just need to move quickly on it and try to give you something to do. By default, though, if you don't know what to do, I always suggest a visual novel, and then you can do two directions for visual novel. You could do education, in other words, use a visual novel to teach people about something, or use a visual novel to actually, tell a story of some kind, or make a game in Pygame. There's a lot of different various games you can make that basically any kind of classic game from a Metroidvania to a up-down, 2D side-scroller to a Mario-like platformer has been made in Pygame, and there's tutorials on YouTube. Those are always a good kind of suggestion for those. But overall, again, you got to come to me for that proposal so I can check you off. Okay? If you aren't able to meet with me on that day, send me an email, right? So that we can find another time to meet. Because you got to turn in that proposal. And you getting it, and you meeting with me is just to make sure that you will actually be set up to do a project with that does an A. That will get you an A and has good milestones for you and a good kind of deliverable target. Okay? And good kind of fallbacks if you can't make it to your target. Got it? Once again, this does need to be turned in. The way to instantly fail, so basically besides cheating, there's only one way to instantly fail your final project, which is not to turn this in, not to have this done by the time the progress report is due. Right? So suppose you just don't come to the proposal and you don't do anything, right? And a round rolls April 22nd and you realize, wait, next week is the final project is due and I didn't even start on it, I don't even have an idea. At that point, it's too late, in my opinion. In that point, it's I'm normally very lenient with late work and that kind of stuff. But over here, this is where I have a hard cutoff because it's never worked well. Got it? If you're not done with your project by the 29th, what do you do? Yes? You turn in what you have. You turn in what you have. And I will go over this in more detail on as we get closer to the final project. But the way I look over your final project is that you will give me a 2 to 3 minute video. Not a 9-minute video, not a 15-minute video. Students do that, and it frustrates me because I then have to basically not watch the entire video. Instead, I have to turn it on to double speed. Now, lie, all the videos are already on double speed because I have to go through them very quickly. But then I have to jump around your video and not give it, and I may miss things that you consider important because I can only dedicate so much time to each video. But basically, that is your demo. You show me what you did. It's very simple to do a screen recording. I'll go over that, but basically that's the main way I look at your project. You show me what you did. I'll glance at your code to make sure that it's on GitHub and you have code there. But that's what you're primarily turning in. All right, makes sense? Okay. Again, this shouldn't excessively stress you. Of course, it's an assignment. It's going to cause you some amount of stress. It's just the way that things are. Okay? But it's not supposed to give you an inordinate amount of stress over anything else. It's not. This is about getting the opportunity to learn something you normally wouldn't learn, an opportunity you would have to do an assignment of your choosing for something that you are passionate about that you normally wouldn't have. Okay. And again, over here, yeah. We are interested in whatever challenges you encounter in coding, and if you found a way to go around them or overcome them. We understand it may not be possible to complete your original vision. We are interested in how you responded to the face of adversity. We're interested in the journey, not the destination. The guidelines for an A, basically speaking, are it amuses me for a minute, amazes me, makes a positive impact in the world, no matter how small. I'm a very easily amused person. Okay. And again, it's a lot of, the reason I continually do this is that a lot of students find this to be a very valuable opportunity and very valuable process. I could go on into other, in more detail and give you assignments on sorting or searching or other base computer science kind of curriculum or do more about 2D arrays, but I find people really enjoy doing this. I mean, we're going to still focus on some of the stuff like definitely manipulating through two-dimensional arrays. I feel like you definitely need practice for that for 1068. But again, I feel like this is a very good opportunity. Now, speaking of which, you also have an upcoming assignment due next week. Pig. So let's get started on that, shall we? Okay. And I do mean started on it. I said that we'll cover at least part 4 through class. Okay, which means, so this part has 8 parts. Each part is worth 25 points, which means that I'm essentially giving you 100 points for free. So there's no reason not to do this assignment because I'm giving you half of it, at least half of it done. So, okay. So Pig is a lot of fun, by the way. It's a game. It's actually the wrong animal name because it's more of a game of chicken, as I've mentioned. It's a dice rolling game. And this allows us to do some practice on Monte Carlo and on dictionaries. Okay? So it's a 2-player game, but we're going to build up to that 2-player mode. Okay? So it has 2 modes. 2-player mode, as well as, so playing against another person, and then also playing against a computer. So, this guy, Todd Neller, who came up with the assignment, did a lot of data analysis to figure out what his strategy is, what strategy a computer should use. It's a fairly straightforward strategy. And then what we're going to do is we're going to build a number of smaller exercises to build up to our final implementation. So this is one of those cases where basically we'll have about at least 8 functions, each of which is going to slowly build up, some of which we can use the other to call. But first, let's actually go over the game of Pig. The goal of the game of Pig is to collect 100 points. It's a 2-player game. Nothing stopping it from being a multiplayer game, but it's a 2-player game. Okay? Very simple rules, and you play it using a 6-sided dice. Okay, 6-sided die, a D6 for those of you in the D&D lingo. Okay? So what you do is that you roll the die until you are either satisfied with the total number of points you gained or you roll the 1. Okay? So basically you have 2 actions. You can either say, I'm going to roll or I'm going to hold. Like in blackjack where you can say hit me or stay, right? You roll or hold. If you roll a 2 to 6, you get that number of points added to your turn total, your total for the turn, and your turn continues, okay? And you can make that choice again. Roll again or hold, okay? If you roll a 1, however, that's the end of your turn. You made no points. You lose all the points you made this turn. Not all your points you've stored up, but all the points you've made this turn, right? And then it goes to and now it's your opponent's turn. So basically what you do is you're going to want to roll the dice at least once, right? Because if you hold the first time, you're just not going to get any points, right? So you roll the dice until you get five points. But your opponent's 15 points ahead of you. What do you do? Should you take those 5 points so he's only 10 ahead of you? But now it's his turn, and he's probably going to get more points. So maybe I need to risk rolling for more points, right? That's the game, okay? Basically, to go big or go home. The question is also, do you want to keep going? And then there's other questions we can answer, like, what is the chances of winning if we decide to go big and go or go home? In other words, we're only going to roll. We're never going to hold. What's the chances of winning of doing that? It's actually surprisingly large. It's very tiny, but much larger than what you'd expect, which is that it's not in the thousandth. Okay, so does that make sense? These rules, right? You either, so what I could do is that it's like my turn, right? I'll roll, okay? And if I got 5 points, great. Then I'll roll again. I get 6 points. I'm at 11 points, and I'll decide that's a good score. I'll hold. Then it's the other person's turn. He'll roll 5, a 3. He'll hold. He has 8 points. I have 11 points. My turn. I roll a 2. Okay, that's not many points. I'm going to roll again. 6. Okay, I've got 8 points. I want to get even higher. A 1. I've lost all my points for the turn. My turn ends, but I'm still at 11 points, right? I only lost the points I rolled this turn. Make sense to everybody? You can think of the points you've already scored as kind of a bank. You can't lose those points. It's only the point it's basically, are you getting points this turn? The 1 just means you get no points this turn. Okay. Otherwise, this game would take forever. Okay, and at that point, you might as well just keep rolling until you win. So. So the guy who came up with the assignment figured out basically he has a pretty nice strategy that he finds works for the computer. A very easy strategy for the CPU to use, which is that the goal of the computer is that the computer will try to get to at least 20 points. Once it gets to 20 points, at that point it will hold, right? This is a very non-determinate, this is a very decision. It doesn't need to make any decision. It just it doesn't bother looking at your score, doesn't look at how close you are to winning. It just says, I need at least 20 points, okay? So we'll call this strategy hold at 20, okay? Make sense? So the first thing we do in this is that we'll make a program that implements this hold at 20 strategy. Okay, we're going to just simulate a single turn where they keep rolling the dice until they roll a 1 or they get at least 20 points. Okay? So what we'll do is that every time, for each roll, a line with roll and the random dice value will be rolled. And then after a pig roll of 1 or a hold, it tells me how many points. So this is some sample outputs. A roll of 4, 5, 6, 5. That's 20 points. So it says, aha, 20 points. Here's another output. 3 points, 1 point. 3, and then a roll of a 1. Turn total, 0. 5, 2, 3, 6, 5. That gives me 21 points, so I stop. Notice it doesn't go up beyond, it can get over 20 points, but once it gets to a value over 20, it's going to stop. So what is the maximum value that the computer could then score under this strategy in a turn? Right? What's the sorry? 20, not 25. Because because the closest you can get to 20 without stopping, which is your stop point, is 19 points. And the highest thing you can roll at 19 is a 6, so that you would end your turn with a 25 then. So that's the most points that's possible under this strategy. But this does mean you're going to win in at most 5 turns. Five successful turns. The question is that we need to figure out is how successful this is. So we'll do this, one automated turn of pig. Part 2 is that we will figure out how good of a strategy this is. And we'll figure out, okay, how often does this strategy pay off for us? And we can then, in part 3, take a look at how successful different strategies would be. Make sense? So part one, we're gonna do this. We're gonna do this. We're gonna do this. Part two, we'll do this strategy. And then parts 2 and 3 are some statistical analysis. And how do we do that statistical analysis? Well, we're gonna simulate. We're gonna roll the dice a bunch. We're gonna do this automated turn a pig like 100,000 times and calculate what the results are. That's a Monte Carlo approximation. All right. Enough of me talking. Let's get coding on this. Okay. So first thing we're going to need is, because we're dealing with dice rolls, is that we need a random. We need to use random. So what I'll do first is I will save this to make sure I have this. Save it on the desktop. And I will call it pig. Because that's what it should be called, pig. Okay. Next, import random, because we know we need a random. Def. And then the next thing we need to do is we got to make we want to make a function that does this. We want to make sure that these are separated into functions, so that as we go, we can modify these functions or copy them to make our job a lot easier, so we don't have to repeat code. Okay? Automated turn a pig. Def, let's call it auto turn. No inputs for right now. If we need inputs, we can add it later. Okay? And what we're going to do is that we've got basically a target score. Let's go ahead and put that in rather than trying to remember 20. Right? Target is equal to 20. Makes sense? And then we'll want to keep track of how many points we made this turn. How many points? And that's going to start out at 0. And I'm going to call this turn total, okay? Because I'm not going to call it score. Why? Because we do have a score. That's going to be the total number of points we have. And I don't want to call this total, because what's the difference between total and score? I want to be more specific, so I'm going to be more specific. We're going to use something called turn total, because it explains it. It's the amount of points we made this turn, right? As opposed to, however many, as opposed to not making it. So let's see. Let's go ahead and first program this without the 1, okay? Let's program this without worrying about the 1 yet, right? Make sense? So while turn total is less than 20, we don't need to return anything. While this is less than 20, how do we roll a dice? I'll make a function for that right now. I really shouldn't do that like that, but let's go ahead and just roll. Because I'm going to do this so often, I'm just going to create a function that does this, called roll. And even though it's only going to be one line, I still find it easier to just kind of show it like this. Return rand int 1 through 6. Let's go ahead and I'm going to go ahead and test this a few times to kind of show that it's going to do a bunch of rolls. So nice thing I can do in idle is I can just do this, and then I can say I can run it, which looks like it does nothing, but it actually ran code. For in range 100, I love this about idle. Print roll, which is a function I just wrote. And then hit enter on, oh, come on. Rand int is not defined. Oh, because I got an error, so I have to run it again. Now I do this. Rand int, oh, right. Random.randint. Right. And there we go. And I'm seeing all values from 1 to 6. So that's great. So this works. So while the turn total is less than 20, we'll say R is equal to roll. So that's the value, like, let's go ahead and call that like value is equal to roll. Okay. We'll print that out. Roll equal, let's see, roll comma value. And then turn total plus equals the value. So we increase turn total by that much. And then when we're done, we would say, let's see, pig, we print out, and then when we're done, we'll say print turn total is less than print turn total. Sorry, I'm just thinking ahead of how I want to teach, of how I want to program this, because I'm going to teach some weird stuff in here too. Print turn total Okay. So run it, except now I'm going to copy the name here, copy it over here, paste it over here, run it, so we can see 4, 3, 2, 5, 2, 1, 6. So if we add all those numbers up, right, so 6 and 4 is 10, 3, 2 is that's 5, 5 and 5 is that's another 10, and 2 and 1 is 3, so that gives us 23. Okay, let's go ahead and add a colon there. So now let's go ahead and implement the 1. So we roll this, and now we want to do something different if it's a 1. So there's a different kind of, there's a few different ways we can do this. If value equals 1, then we need to figure out how to stop it. Else and we'll take this print statement and we'll just put it over here. All right. The reason I've broken it up like this just for a second and skipped ahead is that I want to say something. It's very important that we don't write our code in any way that resembles this. So it's value equals the 1. And this is a very common mistake I see on exams. Why don't we want to do that? Yeah, that generates a new random number each time we call roll. So I say, sorry, not a value. Sorry, not this one. I got ahead of myself with this one. There, that's what I don't want it to resemble. Right? There we go. Because each time I call roll, it generates a new random number. So I roll this number, I could roll 1, and then I'd say, if this random number I'm generating here is equal to 1, right? And that'd be a bit of an issue. It's because, and then over here I generate yet another random number. So I'd be doing 3 different separate dice rolls and getting 3 different values. So that's why I rolled it once and stored it as value. Okay. So if it's equal to 1, there's a couple different strategies I can do here. Regardless, what I need to do is that I need to say that the turn total is equal to 0, right? Because we lose all our points for the turn. And then I need to stop this function. There's a couple of different, stop the loop. We need to stop rolling. Okay? We can either do that with a break there. Does everybody remember what a break does? Yep, stops the loop. Another way you could do that is that we can say roll, and I like doing it like this, rolled 1 is equal to false, right? And then what we'd say is while turn total is less than 20 and rolled 1 is, sorry, and not rolled 1. There we go. So just working through the logic in my head there. Okay, so what we do over here is that basically it would say, okay, if the turn total is less than 20 and you haven't rolled a 1, well, as soon as we roll a 1, this becomes true. Not true becomes false, and because both sides of the and statement have to be true, having that, because we just rolled a 1, this side is now false, so we stop the loop. Make sense? So let's go ahead and run this. Rolled a 1, we stopped. Great, good test. 6, 1, we stopped. 3, 4, 1, we stopped. Oh, what a string of bad luck. Actually, that's an amazing string of bad luck over there, but that's okay, as we'll find out. Improbable events happen all the time. 1 in a million chances happen 9 times out of 10. Okay, so as we're seeing, this strategy actually kind of crashes and burns a lot of the time. Okay, so a couple of things we want to do over here is that we want to now test this. So that's part 1 done, by the way. So let's go on to part 2. Okay. Hold at 20 outcomes. Simulate a given number of hold at 20 turns and then report the estimated probabilities of the possible scoring outcomes. Input a single positive integer indicating the number of turns you want to simulate. Larger numbers yield better estimates. Initially prompt the user with hold at 20 turn simulations. On the next line, print score, estimated probability separated by a tab. After the simulations, print a table line for each score outcome that last occurred in increasing order of score. For each score outcome, print the score, a tab, and the fraction of turn simulations that yielded the score. So here's an example output because I find this helps explain that better than the language over there. How many simulations do you want? I want 1,000,000 simulations. Score 0, 20, 21, 22, 23, 24, 25. These are the 5 different outcomes, right? Sorry, these are the 7 different outcomes that can happen, right? 7 different outcomes that can happen. Okay. And then the estimated probability of each. And so we see here that getting a 0 is actually 60%, occurs 60% of the time in the strategy, 62% of the time. Make sense? So we need to show this is the case. Okay, so I'm kind of lazy. So one thing we can do is that I'm kind of lazy, and I don't want to have to copy this and then say like this, auto turn for part 2, right? And then, right, because if I'm doing this on 1,000,000 times, I don't want print statements, right? The print statements would just take forever to print out, right? So instead what I'm going to do, and then I would want to, return. But I don't want to write a second function again. So instead what I'm going to do is I will maybe have a, basically I'll put a flag over here called debug mode, or debug. Let's see if I can do it outside, because I want to set it for debug. No, I'm going to do it inside because I want to make a point. Debug equals true. Or false. I'm going to set it to false. And what I can do is I can change this, and I can say, okay, if debug, if we want to print things, we'll print it. Make sense? So we're only going to print it if debug mode is on. Which is weird, but trust me, it'll make sense in a bit. And then in order actually for this function to actually be useful, I need to return the turn total as opposed to printing it out. Okay. So here, I ran pig and it doesn't do anything because debug is false. If I switch debug to true, and now it prints out stuff again. Okay. And now let's go ahead and do, that's a lot of turns where I'm just rolling a 1. Yeah, it happens, but that happens again 60% of the time where I roll a 1. So yeah. Now, and then if I do this, you'll see that, so now let's do print auto turn, and you'll see the reason for this. So because we turned the value, turn total, it printed out 0 again. There we go, prints out that. And now if I turn debug to false, and run it, it just gives me the values, the total score. I mean, I feel like I'm getting 0 a lot, but that's why we do the Monte Carlo. It's unbiased. It tells us what actually is happening, not what we feel is happening. So let's go ahead and write the second part. Diff. How many hold at 20 turn simulations? There's a reason for my madness, I swear, for doing it the way I'm doing. It's pedagogical. Okay. Hold at 20 turn simulations. So we'll call this, we can either call this part 2, I'll call it hold at 20 sims. And what I'll do is that as the argument, I will take in how many simulations I want. That way I can add the input and output later. The dialogue with the user, I'm not going to bother writing that. I always find that annoying, and it's always easy to add later. It breaks the flow when I'm testing. So hold at 20 turn simulations. So I'll put the trials up here. That's the number of times we do the simulation. And then what we'll do is we will say, so first off, we just want this to run. We want this to run however many times for blank in range trials, right? I want to do the not game, but we called it auto turn, right? And that if I put in 1,000,000, it would do it 1,000,000 times now. Now I need to actually record the data, right? So result equals auto turn. So now I have to do something with that result. I need a way to store it. Well, there's 7 different variables, so I could store it like this. Num0, num0 is equal to 0, num20 is equal to 0. You see where I'm going with this? And then we just simply do 1, 2, 3, right? And then we would have to say if result is equal to 0, num0 plus equals 1. You get the drift with that one? That doesn't seem very elegant, does it, right? In fact, I actually showed you as of this kind of format a while ago as an example not to do, and instead what we want to use a dictionary in this case. We can make it we can do it a lot easier for our we can do this dictionary a lot easier. Okay? So let's go ahead and just make the dictionary. We're going to go ahead and say results over here, or we're going to call it maybe data is equal to this. Okay, and what we'll do is that we will declare, we'll manually write in the starting values. So like 0, so this will make sense as I'm typing 0, 0, 20, 0, 21, 0. I'm lazy. Why am I typing it in myself? For in range data. Again, there's a reason I'm doing this. Not range data. In range 20 through 27. If I data for R in range 27, because those are all the different kind of roles you can make. Data.R equals to 0. Why did I just do this? Well, this is why. And we'll do 2 turns. Doesn't matter. But here, that's my dictionary now. I didn't have to type anything in except for the 0 itself. Right? I could have just simply typed this in instead. I could have just simply have done this as I had started to do. But like I said, I'm lazy. I like this one way because it had less typing involved. Also, maybe perhaps it might be so that I can modify that easily for part 3, which I've already know what that is. So yes, that is why. So this sets up our dictionary. And now all we have to do is, rather than having a giant if statement, where we say if we rolled a 0, if we rolled a 1, if we rolled a 2, well, if we rolled a 0, a 20, a 21, a 22, a 23, a 24, a 25, or 26. Instead, we just do a very simple statement. Data the data for that result, or the count for that result, or whatever you want to call it, plus equals 1. Right? That result, we've seen it one more time. I don't need to check if I've seen it, by the way, because I know what all the possible outcomes are going to be. Make sense? If you know what all the possible outcomes are going to be, you can just simply put them in. And in advance, and then you don't have an if statement. Make sense? Okay. And now what we can do is that we can, again, print our data. Let's go ahead and do this 1,000 times. And just print the data. And now we've got roles. Right? Didn't manage to get it. Oh, 26. It's not going to go up to 26, right? 26 is not what we want. We can't ever get a 26. 25 is what we want. Here we go. So there's our results so far. And if we instead do it as a for loop, right? For for outcome in data, print outcome, comma, data. Sorry, I'm just constantly thinking ahead about how I want to do this, and then data, the outcome. Right? And now I can do that, and now it prints out like this. So here we have, okay, don't need this. So here, let me run that again. Here we have, okay, we rolled a 0 638 times, a 20 93 times, 21 93, but we should normalize this data, meaning we should put it in a value between 0 and 1, right? So what does that mean? It means that basically I want to know the percentage of the amount of times this outcome occurred. The percentage. Unfortunately, that's extremely easy to calculate because this is the number of because we just simply take the number of times this outcome occurred out of how many outcomes, how many rolls we made total. So we just simply divide by trials. Make sense? And now we get a 0 occurred 0.63% of the time, 20 occurred 10%, 21 occurred 9%, and so on and so forth. Okay? So now we can start making this data much prettier, like they asked in the assignment. It wants us to print out score estimated probability, so let's do that. print score, estimated probability, boom, 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 comma. And that doesn't look good because it's all kind of, you know, not easily separated, right? It's all clumped together, I should say. So instead what I'm going to do is I'm going to do comma sep equals /t for both of these. And remember, sep defines how I'm going to be separating the fields in my print statement. And now that I'm separating everything by tabs, it becomes a lot easier to look at, right? That makes sense to everybody? And now we should do this for 100,000 times and see what the results are. And if we want to do what they were doing 1,000,000 times, adding the bit where you ask the user how many runs they want, I'm leaving that to you. I'm not going to bother doing that. That part's just, again, so that part is from lab 2. You know, you should be able to figure out how to do input-output for that. Right? So that's great. That's part 2 done. Part 3. Part 3 says, hold at X outcomes. As the previous exercise, but allow the user to specify the hold value. What is the probability of reaching 100 in a single turn if you allow the CPU to hold at 100? So again, right now we are doing hold at 20. Right now we want to take this, instead transform this into a hold at X. Okay? So, and I want to do this with as little work as possible. I don't want to rewrite this from scratch, right? Okay. So a couple things here. First, I would need, there's actually 2 things I would need to rewrite. First, I'd have to rewrite this outer function that does the Monte Carlo stuff. And don't worry, if you're trying to copy down, I'm going to provide you with the copy of what I've done today, okay? So I'd also have to modify this because this goes to a target of 20. I'd really like this to be flexible, okay? This auto turn to be flexible, right? But I also want it to be easy for my TA to run. So if I run auto turn, right, it's just going to tell me this is how much I got, right? Make sense? Right, I just want it to tell me that result. But I need to be able to modify this value. Well, here's the trick. I'm going to take this line right over here, target is equal to 20, okay? And I'm going to take it and I'm going to move it. I'm going to move it right here. I'm going to move it right here. So first, we're just going to confirm that this works. Yes, it does. It does, in fact, work. It's not going to tell me what target is because target is still inside the auto turn method, right? In fact, I can prove you that it's still in here by printing out the target. What I've done is I've done something called a default argument, where basically if the user provides something, I've taken a line and I've kind of provided it here. And well, actually, it's easy to show what I do if I leave target in here and instead do why I care about this. Auto turn 15. And now it printed out target. Now let me go ahead and take this print statement, move it over here to auto turn, to right below auto turn. It was easy to read. So right there, we've got our auto turn. And it's called auto turn with 15 as an argument. And it says, okay, print out target. Target is 15, even though it says target is 20 over there. Well, the reason why is because I provided it over here. Default arguments work like this. If the user provides nothing, it says, well, he provided nothing, so the default value is going to be 20. But if the user provides something, oh, okay, instead of target being 20, it's going to be equal to the value that's been passed in. Okay? In fact, let's show you this with some other kind of, by using this over here. Moving this over here into that. Target is equal to 20, debug is equal to false. Okay, auto turn 15. Okay, there's two arguments in there. And I can provide either 0 arguments, in which case this is hold at 20. I can provide 1 argument, or I could provide 2 arguments. Now, how does it know that when I say 15, it goes to target and true goes to debug? It's positional. It's positional. That's how. Okay? In fact, we've seen that, but what if but there's one other way we can do it, which is we could do it like this. In a way that you've actually seen this before. In fact, I just did it 5 minutes ago. I did it right over here. That's a default argument. By default, the separator is a space. If I want to change it, I say sep is equal to this. And so the way that works is that I have these names for functions, and because I don't know how many arguments for print, I have to specify that it's that's that. So I can also do this. Auto turn target is equal to 15. So once I start doing it like this, it says, aha, I'm going to look at not the position, but the argument name instead. Make sense? That's bad practice to do. But the point being is now, by moving those 2 lines up into here, I don't have to rewrite this. Well, I do actually have to rewrite this. I have to change this to being from turn total less than 20 to turn total less than target. I should have set that up a while ago. Okay? And now that will work. So, because now it was going for 52, and so now let's go to 15, and debug mode is equal to true. And now I can check. Aha, okay, it stops at 15 now. Make sense? So, let's go over here to this one. I'm going to change this to hold at X. I'm going to say trials. Same thing, number of trials. We're going to feed that in. So because I'm not going to be providing something over here, that's going to be, since I don't do trials equals some number, this is going to be a mandatory argument. You have to provide this. But this hold point is equal to 20. This is default. If I don't provide a second argument, the stopping point is going to be 20. If I do provide an argument, the stopping point is going to be that different place. So we're going to need to abstract this. So our hold point was 20. So if we change our hold point to 30, we don't want it to, so here, let me go ahead and write what I mean, right? Right now, I can say hold at X sims. Yeah, so we're not, I'm not even going to bother writing a second function. Parts 2 and 3 is going to just be one function. Trials. So not trials, but 100,000. No, let's do quickly 1,000. And it still works. Okay, good thing I did that. Oh, because I'm printing the target over here. Remove that print statement. So there we go. And if I say, hey, our hold point is now 40, well, it doesn't update here because I've only added an argument. But I can change this value. The hold point is now 40. So when my hold point is 20, the default assumption is the outcomes are 20, 21, 22, 23, 24, 25, right? 6 different values. So if I want to abstract this, right, I need to populate my data with not 20, 21, 22, 23, 24, 25, but hold point plus 1, hold point plus 2, hold point plus 3, hold plus point 4, and hold point plus 5. Make sense? Because when I was doing 20, it was 20 plus 1. It was 20 plus 1, 20 plus 2, 20 plus 3, 20 plus 4, 20 plus 5. Make sense? So that's why I did 20 to 26. Does 20, 21, 22, 23, 24, 25 doesn't include the 26. So here, all I'm going to do is replace this with hold point, and then hold point plus 6. Okay? And now I'm going to run this, and I'm going to get an error where it says the key data. Why? Well, because I said 0, and now it's going to hold the values 40. So print data, right? I'm just printing this out temporarily. It says, hey, now dictionary is filled with 40, 41, 42, 43, 44, 45. Makes sense? Okay. But now, what we're going to do instead is we are going to, let's see, is that we need to pass the hold point into there. In fact, we called it target over here, so why don't we just go ahead and call it target so that's consistent. I do this a lot, where I try to be consistent, and that means I change what I'm writing. But now, there we go. I've modified this function, and now all I've done is just moderately change the function. I didn't actually have to redo any of the hard thinking I was doing. These default arguments are pretty cool. That's part of the reason I wanted to do this, is I wanted to show you how to use those default arguments. And that's part 3 done. So let's go ahead and answer that last question, which is, what are the chances if we go to 100? Sorry, if we try to get 100 points all in one go, right? What if we just try to win the game, go from 0 to winning the game just on our turn? What are the chances of doing that? Well, I did 1,000,000 simulations. It's going to take a while. Oh, no, it's done. And my chances of winning, of losing, are 98.9%. In other words, 99% chance of losing on a turn, on any given turn. But if I try to go for 100, there's actually a 1% shot I can pull it off. 1 in 100 is actually pretty substantial. It's substantial enough that it appears in our outcomes. It means that you would expect to see it happen once in a while. It also means if you're too far behind, going for broke, so to speak, is a viable last-ditch effort if you're behind 20 points, and your opponent's 20 points away from the goal and you want to get there before them. Sure. I mean, so we can use this to kind of figure out what are some good, what is a good strategy. So, for target in range 10, 101, that's our stopping point, and we're going to go up by 10. And then target. And now I can test a whole bunch of values. So depending on my strategy, right? So if I decide to just simply, my strategy is hold at 10, right? My target is just to get 10 points a turn. I'll get points 60% of the time. 40% of the time if I go for 20, 25% of the time if I go for 30. So only 50% chance of getting 40 and if I try to go for 40. And then honestly, anything from 50 or above is actually fairly comparable because they're all in the 90. There's a 90% chance I'm going to roll 0 for at least for all of them, right? Did this make sense to everybody, or did I lose everybody when I started doing default parameters? No? No, it's fine? You're still confused? Which part? I've got plenty of time, so what's the part? Yes?
I understand. Pretty sure. But I keep getting the key error in...
Did you remember to update this? And this?
It says when we're at number 2, so that would be higher lines. Line 32 and 39 is where there's trouble.
Oh, this is the line 30s over here. Again, I'll send this out so you'll be able to compare your code. Just focus on what I've written over so far. Okay. Which part was confusing?
So the target equals 20. By default, the target would equal 20 unless you specify otherwise.
Yep. So here I tried it for 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100.
Okay.
That's what I did. So this allows me to roll. So if I do this, that's part 2, right? This is part 2 where we were just doing. If I do this though, that's part 3. Make sense? So that allowed me to basically have one function do 2 of the parts. You're not really going to need that for other parts of the homework. I just didn't want to rewrite this. And this is also, I know from previous semesters, a great opportunity to discuss how you can write these default arguments. It's not a feature you're going to necessarily use too often, but when you do find it a use for it, it's nice. So for the assignment, parts 1, 2, and 3 go together, okay? Parts 1, 2, and 3 go together. Parts 4, 5, and 6 go together. And then parts 7 or 8 are the implementations of the full game. So let's look at part 4. Hold at 20 or goal turn, okay? Hold at 20 or goal. Given a player's score, simulate a single turn of pig. Okay, we've done that before. Where a player rolls until a pig is rolled, or the turn total is greater or equal to 20. So this is everything we've done so far in part 1, right? Or the score plus the turn total is greater than or equal to 100. Why does it care? Why does that matter? Right? Because if I'm at 90 points, right, I don't want to try to get 20 points that turn. I only want to try to get 10 points that turn. Make sense? I only need that many points. So I should stop at that point. Okay? That's a common thing I see. That's probably the most common mistake I see in part 8 when you're playing against the computer. The computer doesn't stop rolling until their hold at 20 strategy is done. Instead, the computer should stop rolling when it hits 100 points. When it would hit 100 points. And the way I do this is I test your program and I check, okay, how many points did it get this turn at the end of the game? Oh, it got 107 or 112. It can't get that many. Okay. So let's go ahead and, just for sanity's sake, we will go ahead and write this as a separate function from everything else without using functions, okay? We will just simply do this from scratch. Def. And this was a hold at 20 or gold turn. Hold at 20 or goal turn. Right? So basically we want to return, and this needs to take in an argument, the score. Okay? Target is equal to 20. We want to get 20 points. Okay? Turn total is equal to turn total is equal to 0. Return turn total, right? Again, focus on what I'm writing. Focus less on you trying to copy it down. I'm going to send this out as an announcement, okay? So turn total 20. So what we need to do is something very similar to the while loop we ran up earlier. While, let's go ahead and say rolled 1 is equal to false. While we have not rolled a 1, not rolled 1, and turn total is less than the target. And now we have one more thing to add. And turn total plus score is less than 100. I know that's a long statement, but why? Well, turn total, 100 points is the winning condition. So if the number of points we've made this turn plus the score would bring us to 100 or more, we should definitely stop. Because if we rolled again, we could roll a 1, and then we could lose the points we made this turn and not win the game. We should, if we have the choice between winning versus risking not winning, we should probably win, right? It'd be rather silly for that bug to exist for a computer. And otherwise, it's exactly the same, which is that, which we just simply do, value is equal to, again, I'm just doing the same thing I did up there. I could have copied or modified. I could have modified this further to add yet another argument. And I might. But I figured let's go ahead and do this from scratch. Value equals roll. If value equals 1, okay, in that case we say rolled 1 is equal to true. We rolled a 1, and as a result we need to say, hey, you made 0 points this turn. And this will stop because this entire clause will now be false, which means that the entire that while loop stops. Turn total is equal to 0. Right? And then, well, that's weird. Let's see. Interesting. Well, you can just add in some natural light then, I guess. Not opening on that side? How weird. Oh, it's only 5 more minutes. You'll tolerate it for that long. Okay, if value is equal to 1, rolled 1, turn total is equal to 0. Else, turn total plus equals the value. That's it. Return, nope, that needs to be outside this function. Return turn total. Okay, and then let's go ahead and do this. 100, let's go ahead and do, let's say we're at 98 points. Oh, I had that already written. See, 98 points. Oh, print this out. Huh. 6 points for that turn. So, and now let's go ahead and print out let's go ahead and add in dialogue. But again, I could just do the same thing over here in my auto turn by saying, please provide a score. Score is equal to 0 by default. And then say, and score plus turn total is less than 100. And that's all the only change I had to make to auto turn to get it to working. And then I could just do auto turn and say score, and then I could just pass it, let's say 34, debug equals true. Run it, and then it tells me, okay, turn total is this one, and then I can modify this to print out this. Let's go ahead and modify this, print out score. New score is equal to turn total plus score. So I'm passing in 34 as my current score. I earned 20 points this turn, so my new score is 54 points. Make sense? I can also just simply take this down over here and just simply have, again, or if you're, again, not comfortable with that, we can just simply take this value over here, right? Print roll. And then when we're done, print turn total is equal to turn total, print score is now equal to score plus turn total. And we modify our score based on what got returned later. And so there. So let's see. Let's go ahead and comment you out. Run, and so now we're running hold at 20 or turn. We'll do, say we have 50 points. We'd get up to 70. And now let's say we have 83 points. Okay? So let's do 83 points. Run it. And I got 18 points. So we were at 83, 85, 85, 91, 95. And this brought us to 101. And so we stopped. We didn't roll any further because rolling any further would have risked rolling a 1. All right, so stop recording.